Hello everyone, good evening. This is Sangeetha, Assistant Professor, EC Department, SNS College of Engineering, Coimbatore. So in the last video, we discussed about image segmentation and detection of isolated points. Let us have a small recap of image segmentation. So image segmentation is a basic crucial step in image processing and computer vision that involves dividing an image into meaningful regions or segments. It is mainly used to simplify its representation or to make further analysis easier. And we have studied some types of segmentation techniques, that is threshold based segmentation, edge based segmentation, region based segmentation. And now in this video we are going to see about edge based segmentation methods. So in this edge-based segmentation methods, there are three types of detections, that is point detection, line detection, and edge detection. So these detection methods are fundamental techniques in image processing segmentation used to detect specific features or structures within an image. So these methods are used to identify isolated points, straight lines, and edges, that is boundaries between objects. So they are essential for higher level tasks like object recognition and scene understanding. First, let us discuss about point detection. So point detection is the process of identifying isolated points or small regions in an image where the intensity is significantly different from its surrounding pixels. These isolated points could represent noise, smaller features, or defects in the image. So the Laplacian operator is often used for point detection, as it highlights regions where the intensity changes rapidly. So the Laplacian is a second order derivative operator that detects intensity changes in all directions. And the next one is line detection. So the line detection identifies straight lines in images which can represent edges or objects or structural elements in the scene. So the lines can be oriented in different directions, that is horizontal, vertical, or diagonal, and the special masks or filters are applied to detect lines in a particular orientation. For line detection, the masks are used to detect different orientation or lines. So this mask compute the intensity difference in a specific direction. Mask for line detection is H, that is horizontal line detection. It is -1, -1, and the first row all the values are -1, and the second row all the values are 2, and the third row all the values are -1. And for vertical line detection, the first column all the values are -1, and the second column all the values are 2, and the third column all the values are -1. And there are two types of diagonal detection, and that is -45 degree and plus 45 degree. And for 45 degree, the first row it contains 2, -1, -1, and the second row it contains -1, 2, -1, and the third row -1, -1, and 2. So the last one is edge detection. So the edge detection is a technique used to identify the boundaries between different regions in an image, so where the intensity changes sharply. So the edges represent significant transitions in pixel values, and it is mainly used to define shape or contour of objects in the scene. The edges can be detected by calculating the gradient of the image intensity. So the gradient is a vector that points in the direction of the most significant change in the intensity, and its magnitude tells us how sharp the change is. So there are two types of gradient based edge detection. The first one is horizontal gradient, that is Sobel gradient, and the second one is vertical gradient, that is it is otherwise called Sobel operator. So one of the most popular gradient based method is Sobel edge detection, which uses two 3x3 convolution masks. For horizontal gradient, in the figure it shows the horizontal gradient the values are in the first row -1 0 1, and the second row -2 0 2, and third row -1 0 1. This is for horizontal gradient operator, and for vertical -1 -2 -1 in the first row, and in the second row all the values are 0, and in the third row 1 2 1 values are present. So the magnitude of the gradient at each pixel is computed. Z is equal to root of gx square plus gy square. So these are the three types of isolated points. And so in this video we discussed about point, line and edge detection. So the point detection identifies isolated points, that is pixels, that differ significantly from their neighbors. Example, detecting noise or small features in an image. And line detection, it identifies straight lines in an image. For example, finding road markings in aerial images or borders of objects. And in edge detection, it identifies object boundaries by detecting sharp changes in pixel intensity. Example, contour detection of objects in an image. So each detection method is applied depending on the specific image features or structures that need to be identified. Hope this video will help you to understand the basics of isolated points, that is point, edge and line detection. Thank you, students.